The Andromeda Galaxy was the galaxy that brought to light the fact that the universe and creation itself didn't revolve around us. It was proof that the Milky Way isn't the only galaxy on Earth, and that we might just be a speck in the greater universe overall. Over the past century, we've actually learned a lot about Andromeda, but most of the information has been from Earth. Now that we have access to instruments like the James Webb Space Telescope, things are a lot different. Turns out the Andromeda Galaxy is not what we thought it was. History of the Milky Way. Data from the James Webb Telescope has shocked the entire industry. Join us as we bring you all the details on the truth about the Andromeda Galaxy and the shocking truth about it that we didn't see coming. For an entire century, just over a century ago, the Milky Way was commonly thought of as a band of faint, wispy, whitish light stretching across the night sky. This perception was influenced by the limited technology of the time, which prevented astronomers from discerning individual stars within the Milky Way. People held various beliefs about the Milky Way, often associating it with the center of all creation where the celestial and terrestrial spheres met. Galileo Galilei, an Italian astronomer, was actually the one who revolutionized our understanding of the Milky Way in the early 17th century using his newly developed telescope. He made groundbreaking observations that challenged the prevailing Aristotelian cosmology. He discovered that the Milky Way was not just a diffuse light band but a massive collection of individual stars, planets, and other celestial objects. The Milky Way galaxy, the nearest galaxy to us, is the Andromeda Galaxy, and we think there are about 100 billion galaxies in the visible universe. So, believe it or not, that means we can actually count the number of stars in the visible universe through his observations. He demonstrated that the Milky Way was not at the center of the universe, as previously believed, but instead a vast expanse of stars scattered throughout space. In 1750, English astronomer Thomas Wright proposed a new hypothesis in his work An Original Theory or New Hypothesis of the Universe. According to Wright's speculation, the Milky Way was not a random distribution of stars in space, but a completely flat layer of stars. Plus, he also suggested that a portion of this vast structure was our own solar system. While Wright's hypothesis was a step forward in understanding the structure of the Milky Way, it was still limited by the observational technology available at that time. They all still believed that the Milky Way was all there was to it, and considering the limitations, that's not surprising. But astronomy made major leaps by the early 1800s, and by the early 1900s, things were changing fast. In the 1920s, Edwin Hubble, an American astronomer, made a transformative discovery using the 100-inch Hooker telescope at Mount Wilson Observatory. Hubble observed distant nebulae beyond the Milky Way. Through the observations and analysis of these objects, he showed that they weren't actually part of the Milky Way, but in fact were entirely separate galaxies, each containing billions of stars. One of the closest of these galaxies was the Andromeda Galaxy, also known as M31. It has a rich history of observations that dates back centuries. One of the earliest known records of this celestial object can be traced back to the 10th century, when the Persian astronomer Abd al-Rahman al-Sufi described it as a small cloud in star charts from that period. It was labeled as the Little Cloud, which might have to do with the fact that when you examine it from Earth, it does seem like it has a faint cloud all around it. The significance of these observations lies in the fact that al-Sufi was able to identify this distant cosmic entity without the help of telescopic instruments, relying solely on his keen eyesight and observations. He was able to do that because Andromeda is one of the only galaxies in the universe that you can see from Earth's surface without needing any special instruments. All you really need is to know exactly where to look, and you'll see it right there in the open sky. Sure, you can't go into much detail about the history of Andromeda, but you can still see that something other than the usual stars is there. That's why it wasn't until 1612 that a more detailed description of the Andromeda Galaxy, based on telescopic observations, was provided by Simon Marius. His work ended up being what laid the foundation for future astronomers to study this massive cosmic structure. Later in 1764, the renowned French astronomer Charles Messier catalogued the Andromeda Galaxy as M31 in his well-known Messier catalogue, mistakenly attributing its discovery to Simon Marius. Unaware of Al-Sufi's earlier work, but that doesn't mean that he didn't have a major hand in putting Andromeda on the map. For almost 100 years after this, astronomers all over the world were trying to understand more and more about this mysterious galaxy, each adding to the last one's findings. A significant leap in understanding the nature of the Andromeda Galaxy occurred in 1864, when the English astronomer William Huggins made a groundbreaking observation. He studied the spectrum of Andromeda and noticed that it was different from that of a typical gaseous nebula. That paved the way for the world to really get to know Andromeda for what it really is. And while it's a lot, the Andromeda Galaxy has a mass estimated to be between 1 and 2 trillion times that of our Sun. It's a colossal cosmic structure that just happens to live relatively close to us in the vastness of space. In all the research conducted until now, scientists believe that Andromeda is about 10 billion years old, making it quite ancient in cosmic terms. Its age hints at a long and intricate history of formation and evolution. One of the intriguing aspects of Andromeda's origin is the hypothesis that it came into being through the merging of several smaller proto-galaxies. This suggests that over billions of years, smaller galactic entities gradually came together under the force of gravity to form the majestic Andromeda Galaxy we see today. Such galactic mergers are common occurrences in the cosmos, shaping the growth and structure of galaxies. But it all happens so slowly that you can't actually see it happen until major progress has been made. For a long time, astronomers thought Andromeda was significantly more massive than our own Milky Way galaxy. From an objective point of view, a mistake like this could easily be made because we're in our own galaxy, and seeing Andromeda from Earth does make things look so large that you'd easily think that there's no way anything could even come close to its size. But that's not the case. Recent Andromeda's active galactic nucleus research has brought about a reevaluation of these beliefs. New findings have led scientists to somewhat reduce their estimate of Andromeda's mass, while simultaneously increasing the mass attributed to our Milky Way. The Andromeda Galaxy's physical dimensions, though, are what astronomers totally agree on. It's known to stretch farther than our own Milky Way, with an impressive diameter of about 220,000 light-years. Andromeda surpasses the Milky Way's estimated diameter of roughly 100,000 to 175,000 light-years. This vast size makes Andromeda a truly significant cosmic entity, taking over a large region in space. This revised perspective also highlights the complexities and challenges of accurately measuring the mass of galaxies. Galaxies are immense systems, and their mass is intricately linked to the distribution and movements of stars, gas, dust, and dark matter within them. Pitting these values precisely is a demanding task that requires sophisticated observational techniques and meticulous analysis. So it couldn't have possibly been done in the 1700s or even in the 1800s. This type of knowledge required modern tools, which is why the reality is just coming to light now. Although by far one of the most fascinating features of the Andromeda Galaxy is its active galactic nucleus, AGN. The active galactic nucleus, popularly known as AGN, is a highly energetic region at the center of a galaxy. It is characterized by intense emissions across various wavelengths from radio waves to X-rays. AGN are powered by the presence of a supermassive black hole at the heart of the galaxy. These supermassive black holes are incredibly dense regions in space where an enormous amount of mass is concentrated within a very small volume. When astronomers observe the active galactic nucleus using advanced telescopes like the Hubble Space Telescope, they notice a very interesting phenomenon. The AGN appears to have 2 points of concentration, meaning there are 2 distinct regions where light and other forms of radiation are emanating more intensely than in the surrounding areas. The brighter concentration is the second point of focus, which is just slightly off the true galactic center. Within this area lies the supermassive black hole. The mass of this black hole has been estimated to be between 1.1 to 2.3 multiplied by 10 to the power of solar masses, which means it weighs approximately 110 to 230 million times as much as our Sun. Supermassive black holes are believed to be common in the centers of galaxies, including our own Milky Way. As a result, they play a crucial role in the evolution and dynamics of galaxies. When matter, such as gas and stars, gets too close to a supermassive black hole, it forms an accretion disk around it. This disk of swirling material heats up and emits intense radiation across various wavelengths, which is why the AGN is highly luminous. When astronomers observe the active galactic nucleus of the Andromeda Galaxy, they notice a brighter point of concentration near the central supermassive black hole. This feature is a result of the unique gravitational interactions between the black hole and the stars in its vicinity. In the heart of the Andromeda Galaxy, the supermassive black hole exerts an immensely powerful gravitational pull on surrounding stars. As these stars orbit around the black hole, they follow elliptical paths similar to planets orbiting the Sun in our solar system. This dynamic gravitational dance between stars and the central black hole creates a highly energetic environment that radiates intensely across the electromagnetic spectrum. The study of Andromeda's active galactic nucleus provides crucial insights into the physics of supermassive black holes and their influence on galactic evolution. These phenomena are essential for understanding the formation, growth, and dynamics of galaxies throughout the universe. Andromeda's AGN serves as a nearby laboratory for astronomers to explore the intricate processes that shape the behavior of galaxies over cosmic timescales. Beyond its active nucleus, Andromeda's vast scale and complex structure continue to captivate astronomers and researchers worldwide. Its sheer size and proximity make it a prominent subject of study, offering valuable comparative insights into the Milky Way and other galaxies. With ongoing advancements in observational technology and theoretical models, scientists are poised to uncover even more about Andromeda's mysteries, shedding light on fundamental questions about the universe's origins and evolution. As astronomers continue to unravel the secrets of Andromeda, they not only deepen our understanding of our cosmic neighborhood, but also enhance our perspective of the universe's vast and diverse landscapes. Andromeda stands as a testament to the relentless pursuit of knowledge and discovery,